Hi, everybody. I'm going to try to use Zoom to record a short lesson. I hope it's not a disaster. We'll see how it goes. So I'm going to start by trying to share the .cam screen. We'll see how it goes. Okay. So this is from your notes. Hopefully you have them with you. This is page 12. It is section 5, locating zeros of a polynomial function, and also when a polynomial is positive and negative. So the first example asks you to determine between which consecutive integers the real zeros of this function are located. And so I know we could just graph it, right? We could just graph it and look at it and probably be able to tell. Before mathematicians could do that, right before they had nice handy-dandy graphing calculators, they would kind of just look at a table of values and try to be able to figure that out. And so here's an example. There's a function, and if you just look at these questions and see if you can maybe have some guesses here. So between which consecutive integers are the real zeros located? Right? How do you know? For which values of x is the function positive? How do you know? When is it negative, increasing, decreasing? Okay, so how do I know I have zeros? So as I'm looking at my y values, I'm noticing they're positive, they're decreasing, right? They decrease. And then here they're switching from positive or negative. So that means somewhere in here, right, between this value and this value, it must have hit 0 somewhere in between. So there must be a 0 located somewhere between -3 and -2. Right, and then as I look, okay, -1, -1, so maybe it stayed constant, maybe it did something in here, maybe it got lower and came back up, and then I see it's increasing, increasing, increasing. Again, here when the signs are switching, right, between negative and positive, then what that means is there must have been a 0 in there. And so we're thinking, okay, what are the x values for which, you know, there was a change, where the 0 was? So we could say between -1 and 0. Okay, so then for which values of x is the function positive? And so here we see a positive y value. So when we're talking about, it's like when we're doing increasing and decreasing, it was like for what x values was y increasing, for what x values is y decreasing. This is now asking for what x values is the function positive. So right now it's positive from, if we want to use interval notation, we could say from -6 to -3. It's positive. Okay, and then here I'm seeing that my y values are negative, so I could say from -2 to -1, it's negative. And then it's positive again. So it's, again, we're using the x values to describe when the y values were positive or negative. And then for which x values is the function increasing. So when I'm looking at this right now, it's decreasing, right? And then, so from here to here, decreasing. So those x values are from, this is decreasing, right? So -6 to -2. And then here it turns and it starts increasing. So I could say from -1 to 4. Okay, so that's how mathematicians used to figure these questions out. They would just look at a table and then, you know, make some observations about it. Now we can use our calculator. So I'm going to try to switch to maybe I want to switch to decimals. Let's see if it'll let me do it. No, guys, this is hard. I don't know what I'm doing. Do you know that? All right. Let's see. Any chance? Decimals. Okay, hopefully you can see what I'm talking about here. All right, I'm going to enter in that equation so that y equals 12, whoops, equals would help, x to the third minus 20x squared. Because again, I did not bring my Inspire home, so I'm going to have to do it like this. Now, in the Inspire, you can, you know, look at it and calculate your zeros. So this example 1 asks between which consecutive integers the real zeros are located. And so I can click on these, click, 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 right? And the question is between which consecutive integers. Here it would be between -1 and 0. And here it would be between, oh, what is that? 0 and 1. And then here it's between 1 and 2. So that is how I could use Desmos to kind of figure that out. I could also look at a table. Like if you graph this into your Inspire, you could put in the equation, you could look at the table and then see like where the signs switching between positive and negative. So that would be how you could do that. All right, let's see if I can get back to, oh, I did it. Amazing. All right, now I want to share the dot cam. Is it gonna work? All right, so do I remember what I just said? No, I don't. All right. So where did we have in Desmos those intervals? Like we had one between 0 and 1. We had another one between -1 and 0. Good thing I have my answers written down. Another one between 1 and 2. Okay, so that's all you would have to do for those. All right, example 2 asks us to approximate the real zeros. So again, I would put that in my calculator. In the Inspire, I would have it calculate the zeros, or if I'm Desmos, I would graph it, click, and then also the intervals on which the f of x is positive and negative. So let's see if I can go back to Desmos. We can do this, right? Maybe. Calculator, look it. Okay, so let's get rid of this guy. Let's type in example 2. Feel free to do it while I'm doing it. What else are you gonna do? All right, 16x to the third, and then minus 18x squared, and then plus 5. Whoops, 5. Let's make sure I type that in right. Looks like it. Okay, so where are the zeros? So again, if I were in the Inspire, I would just do the analyze graph business. So at -0.442, another one at 1, another one at 3.775. I'm just jotting down those ordered pairs so I don't forget them. Okay, so then I want to give the intervals when this is positive and negative. So positive intervals are when the x values for which the y values are above 0. So if I were tracing this graph, we kind of did something similar when we were talking about increasing and decreasing. So first, really quickly, I'm just going to sketch this on my paper, so we can come back to it. Okay, so as I'm tracing it, think about what are your y values right now. All your y values are, as I'm tracing this, they're all negative. Okay, when did they stop being negative? When I get to the x-axis. So how would I describe that? I want to describe the x values for which that's true. So it's all these x values back here. So we would say it's negative from negative infinity until I hit that -0.442. Okay, then if I keep tracing, all my y values are positive, right? And they start out being positive here, and they stop being positive here at 1. So it would be positive from -0.442 to 1. Okay, and then it's still, as I go and trace along here, it is still positive, but I have to think of this as 2 different intervals because technically here, it's the y value 0, that's not positive or negative. So I'd have 2 intervals there, right? The -0.442 to 1, and then the 1 to the 3.775, okay? And then from here on out, the 3.775 and on, the y values are negative. So then I would say from 3.775 to infinity, the y values are negative. All right, so let's see what I wrote down here I wrote all this down as we were going. Okay, so here's my sketch of my graph right here. Guys, I don't have all my highlighters. It's really hard for me to not have my highlighters. So I'll just try to bold this in. All right, so we started out down here, negative, right? Remember the x value here was at -0.442. So these y values are negative here, and I want to write the interval for the corresponding x value. That's where this came from. No, that's where this came from. All right, then here, all of these y values are positive. So from this x value of negative 0.442 to this x value, which was 1. That's where this guy came from. All right, then I had to have a separate interval for this one because, right, technically at 1, that the y value is 0, it's not positive or negative. So I had another interval here, right? So that was from the 1 to the 3.775. That's this guy here. And then all of these y values are negative. The x values that correspond to that are from 3.775 to infinity. Okay, so example 3 asks you to do basically the same thing. Okay, so you're going to graph that. You're going to figure out what the zeros are, and you're going to give the intervals where it's positive and negative. Okay, so I'm not going to go back to the decimals because it's stressing me out. I'm not lying, it's going to stress me out. All right, I'm going to sketch what it's going to look like. So it looks like something like this. Okay, there's the graph. It's a cubic. I'm going to fold this paper over so we can see it better. Okay, there it is. Okay, I would get my zeros, just click, 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 get your zeros. So this is negative 0.51. Okay, this is 0.71. This is 1.38. Okay, so when it says approximate the real zeros, okay, zeros are just x equals negative 0.51, x equals 0.71, x equals 1.38, or you could write them as ordered pairs. That would be fine too. Okay, and then we want our intervals when it's positive and negative. Okay, so if I were to trace the graph, starting out, this is negative, right? The y values are negative here. I want to describe the x values for which the y values are negative. So it's all of these guys here. So from negative infinity to negative 0.51. Okay, then here, those y values are positive. I want to describe the x values. So negative 0.51 to 0.71. Okay, negative here to here. So 0.71 to 1.38. So this is the negative and then positive. I'll try to find my highlighters for next time. 1.38 to infinity. And it's always parentheses because technically at the zeros, it's not positive or negative at zero. It's just like when we're increasing and decreasing at the max and the mins or relative maxes and mins, it wasn't technically increasing or decreasing. All right, last one, the Toaster Treat Company uses a box with square bottom to package its product. I'm guessing this is something like a Pop-Tart. The height of the box is 3 inches more than the length of the bottom. Find the dimensions of the box if the volume is 42 cubic inches. So maybe take a second and sketch this. You just know I have a square bottom. So something like this. It's not too bad. Okay, but it's a square bottom. I know the height is 3 inches more than the bottom. If it's a square, I know on the bottom, the base, the length and the width are the same. I'm going to call those both x. And then if I know the height is 3 inches more, I'm going to call that x plus 3. That means that x times x times x plus 3, right, length times width times height, has to equal 42. So that's then x squared times x plus 3 is 42, and then x cubed plus 3x is 42. And then basically I want to know what x is. I want to solve this. So if I want to solve this, I'm going to ship this 42 over to the other side. And basically what I want to do is I want to find the zeros. Okay, so graph this. Pencil just broke. Because it's, oh, it is a 0.9. Usually I use a 0.9. I thought it was a 0.7. It is. Enter into calculator and find the zeros. Right, you get 2.7. So x is 2.7. So that means our dimensions are 2.7 by 2.7 inches, right? This is 3 inches taller by 0.7. Okay, that's it. I hope it wasn't too long, too boring. I hope you guys are good. I hope you're staying home, staying with your family. I'll talk to you later.